written your fancy Ajax JavaScript code, and it works really great on your local web browser, talking to localhost or reading off the file system. And you're at the point where it's time to start, shipping the app to real users. To say, okay, visit, fooapp.com. So they go to their web browser because, their friends tell them about it because you've got this really cool app. So what happens? They go to the browser, they type in, fooapp.com. So, you kind of sort of hear, okay, we do a DNS lookup, we send an HTTP request, and we get some contents back. And while that is generally the case, there are a number of subtleties just in this action alone that can really affect how quickly your application loads, how effective it is, how robust your overall application structure will be. So, in order to talk about deploying web apps, we need to talk first a little bit about how we get content from your server back into the client browser. So let's start off with a DNS request. So, you type in, fooapp.com. The machine has never, had any interactions with fooapp. You've never visited before. It's first-time visitor. So the local machine is going to have to query its DNS server, and that might be the ISP, that might be a corporate proxy. There are innumerable different ways in which this can be constructed. So what you wind up doing is first, you break it down with, fooapp.com. So DNS is recursively resolved. We first start by finding the start of authority records for, .com, which is probably going to be cached since that's a very, very popular TLD. But if you are operating under a less frequently used TLD, .cc, .foo, .whatever, you might not actually have cached entries for that particular TLD. So you wind up going to one of the root servers, finding, an authoritative server for .com, and you go ask that, what is fooapp.com? And you resolve this recursively, sort of working from right to left, com, fooapp, and you might even have a more detailed structure, images.fooapp.com and whatnot. So at each of these stages, you go and recursively ask for, the A record or whatever particular record you're looking for, and that can take time. You can spend a non-trivial amount of time waiting for DNS to be resolved. So this is one of those things you kind of have to think about when you start planning your deployment strategy. What are the different host names I'm going to use? Are they all going to be the same? Do I want to have an opportunity for global load balancing? Because if you control your own DNS servers, you could say, okay, people who look like they're coming from New York, they will get an IP that is being hosted by a server in the Northeast. People who look like they're coming from California will get an IP that looks like that is served by a machine in California. So you can do very coarse global load balancing as part of your DNS setup. And okay, so now we say, okay, I'm going to send an HTTP request. So what's really going on when I send an HTTP request? Well, the first thing I need to do is I need to establish a TCP session just to be able to send that GET request. And that's not just, it doesn't just magically happen. You wind up having to do several round trips between the client and the server just to establish the communications channel through which you're going to send the HTTP request. Even just looking at the three-way handshake. You send a send packet, you get a send ACK back, you send an ACK, and only then are you really able to start having a real bidirectional communication channel available for your use. So you wind up needing a couple of round trips, and remember, each round trip is of a non-trivial delay, especially when you're talking about a residential broadband, or even worse, people who are still on modems. I think, broadband penetration in the U.S. is, 50, 60%, give or take. So if you are really trying to target everybody everywhere, you do need to be aware of the fact that, that the latency between their client and your server is multiplied by even just setting up, your communications channel. And then let's talk about SSL, right? You're doing banking, you're doing e-commerce, you want to have a secure messaging channel. So even then, you're going to need some additional time and bytes consumed to negotiate your SSL connection. I need a certificate, I need to verify it. If you have particularly secure settings for the browser where it wants to check the certificate revocation list, they might go do some side requests and check the CRLs to see if your certificate's dead. So as sort of a summary point there is connections are expensive to set up and maintain, regardless of the particular technology stack they're using. Even just plain old HTML pages. You need to be aware in the back of your mind as you're designing your application, how many connections do I need? So now we're going to get the contents. So remember, I typed in, fooapp.com, hit return. I now have a connection open. I send the HTTP request. This is, sort of an excerpt of what the conversation looks like. So I go and I say, okay, I want slash. And this is my virtual host. And the server says, okay, go here instead. You see this a lot. I go to some website.com and I eventually get redirected to website.com/content managed server /pages/page0.html. This is how the conversation plays out. But what you can wind up with is, okay, so it tells me I've moved temporarily, I should go fetch this URL. And I do another request to get the URL it just told me to go get, and I got redirected again. This happens. And while it doesn't negatively affect the user experience directly, because eventually they wind up in the right place, you need more and more round trips just to get to your landing page. And these are the kinds of things that do add up over time. It's, once, twice, it's okay, but if you're building an application that you want people to visit all the time, you want to build the next, Facebook or whatever, things people hit all the time. Not only is the number of cumulative user seconds being lost waiting for redirects, you have to do that many more queries just to redirect the person to the final landing page. So again, when you're thinking about your URL structure, remember that you want to try to minimize the number of redirects. If possible, when they request slash, maybe you can send them the final page that they want and sort of redirect them in the background. And again, it happens all the time, especially when you start having multiple different host names. If I have images.foo.com and static.foo.com for my different kinds of contents, I still have to do another DNS lookup. I have to establish another new TCP session. Then I have to send HTTP requests, and so on and so forth. So you can wind up with having quite a number of connections that are necessary just to be able to pull down your landing page. So we want to minimize the number of connections required to start your app. Things like TCP Keep Alive and HTTP pipelining really will cut down on the number of connections on TCP sessions required, so you can spend more time serving the content. So, and by the way, this is just to get your landing page. This is just to get foo.html. So I have all this static content, and I've got the landing page, I've got the JavaScript, I've got all the images and stuff like that, and my JavaScript app is started up. So now what do I do? Well, the other thing you have to think about is, for non-trivial applications, they tend not to be just, one chunk of JavaScript. They're probably, maybe another bit of JavaScript here, some more images, some other static resources. I've got some RPC requests that are going on. It's a very dynamic application. The kind of things that people expect with, with Web 2.0, with Ajax and all the other buzzwords. We have a certain application style that is very rich and very dynamic, requires, many round trips to the server. But when you structure your application, again, regardless of the particular type of technology that you're using for writing the client app, you are limited by what the browser is willing to do on your behalf. Typically, you're limited to either 2 or maybe 4 outstanding RPC requests or any kind of XML HTTP request to the back end. And if you're fetching other static images, other bits of JavaScript, those, depending on the browser, can count against the number of connections you might have for doing active RPC requests. So again, consider, what do I need? When do I need it? How am I going to get it in a way that does not interfere with the experience that the user's having with their application? So in terms of a couple of practical measures to think about, you've got your app. Your app is really, really cool. It does something neat that nobody's ever done before. You know you're going to make $1 billion with it, but it's slow. The user experience that people expect is that applications should be fast. They should respond quickly. When I go to google.com, it just goes boom. It's right up on the screen right then. That's what people really want. And how many websites have you gone to? I go to some website.com and it starts loading and it's just there. And then I get bored and I get frustrated and I never visit the website again. It's not atypical for people to get frustrated and never return to your website. And that's kind of a shame when you have something cool that people didn't use because things were a little bit slow. So Ajax is supposed to be fast. It's what people expect. You do kind of have to manage their expectations. There's nothing worse than, a website that is inconsistently non-performant. If I know that every single page refresh is going to take 2 seconds, you kind of get used to that. It's a workflow. And, so, okay, I click the button, I read my email. I click the button, I read my email. People develop that kind of workflow. I'm sure you've done it with a number of applications. But when applications become inconsistently slow, where sometimes things are fast and then sometimes things take forever, that does tend to increase the frustration level. And that's not good because people don't want to come back to your website because it's slow, it's hard to use, it's frustrating. With Ajax, given that you have a lot more control over the client, you can sort of pick and choose when you're going to incur delays by doing stuff in the background, by deferring things. But it's still just kind of sweeping the dirt under the rug if you're not addressing the underlying cause of why your application is slow. So you really need to start by getting real hard data on why is my app slow. You can just kind of say, oh, it's slow because of X, and you spend 2-3 weeks making X fast, and you realize my app didn't get any faster because I chose the wrong thing to try to optimize. So we have to start with some hard data. And I'm going to start with a little bit of a metaphor for deconstructing your application. So I'm going to say that your web app is a lot like a BLT sandwich. It really is. So what are the components of a BLT sandwich? So you've got B, which are your backends, L, which is your logic that you're applying to whatever you get from your backends, and T for your transport. How much latency am I incurring getting my data from point A to point B? And again, they stack. You can build a 2 or 3 layer deep BLT sandwich, and they're really tasty. So, what are the measurements that are going to be useful to me? You can't just look at saying, okay, my RPC requests take 500 milliseconds, because it's not really a useful measurement to determine where the problem is. It's far too coarse, because there are so many things that go into that 500 milliseconds. So, what do we pick to measure? We can start with things that are internal. We can make internal measurements. We annotate the code, we add some profiling. We, make our client Ajax code, record statistics, and send it back to us. Things that require changes to the application itself. You can build them into servlet filters. If you have a JDBC abstraction or whatever data library you're using, you can build that kind of stuff in there. And it's incredibly useful when you can start accumulating all of these different time series that tell you where in my app am I spending time. We also don't really like min and max measurements because it's so easy for a max measurement to get blown completely out of the water. If you look at just connection timeout to your database, right? That can take 5 or 6 seconds before your timeout kicks in, and now it looks like your max is 6 seconds. Not really useful. Things like decile measurements. What is my 80th and 90th percentile? Those are more interesting in terms of telling you where the long tail begins and where the majority of your requests wind up. You have a monitoring system for these non-trivial production applications. If you don't, you're probably getting called by somebody at 2 in the morning. Let the system call you. You can take these measurements, export them somehow into your monitoring system and say, okay, I have an automated system that says when the 80th percentile response time goes above 400 milliseconds, I get a page. And that's kind of cool because you can, respond to it faster than somebody picking up the phone and calling you and say, hey, your web app is slow. And again, when you're doing internal measurements, don't go overboard. You can take the simplest Hello World application, and you could collect megabytes and megabytes of data about its performance. But then you wind up sort of with the observer effect, where the act of taking your measurements has significantly altered how your application is performing. So you need to think about, where am I spending my time? External measurements are things that we can do without modifying your code. You can use TCP dump. You can use Ethereal, especially with HTTP-based applications. Any kind of proxy server that has diagnostic information built into it can be useful here. We can see how many requests show up, what's outstanding, what's not good. One of the apps that I really like is something called the Charles, which is it's basically just a little HTTP proxy. You set up your web browser to use that as its local proxy, and it'll show you all kinds of data. So, kind of wrapping up part one that I wanted to talk about, and then I'll let Ryan talk about how more specifically you can address things that address these problems specifically with tools and techniques available through the Web Toolkit. So again, none of those sort of performance points and design considerations are specific to using the Google Web Toolkit. They should apply to any particular choice of client and server technologies. All web apps basically look alike in terms of how they're built and structured, but you have a wide variety of how you can choose to implement particular bits and pieces. You have to think about the entire stack. You can't just say, I'm going to use this nifty toolkit on the client and I just let the server go, because that's not really going to give you the best experience overall. You can't start to separate the behavior of the client from the behavior of the logic, from the behavior of its backends and the transport mechanisms involved. They really all do fit together into one cohesive user experience, and when one part's broken, the entire user experience will suffer. Take any of the lightweight profiling that you do as part of figuring out why your app is slow, and roll that into your monitoring environment, just because it becomes useful down the road. I can make my systems know more about how they're performing and alert me when things get broken automatically. And start by setting concrete goals. Like, you can't just say, I want my app to go fast, because it doesn't really allow you to set goals, set milestones, and whatnot. So just say, okay, I want my application to start up and be available in 300 milliseconds from the time I press enter. And that at least gives you something to shoot for, because then you can set up a budget and say, okay, I want to spend no more than 80 milliseconds marshaling and transporting the data. I want to spend no more than 120 milliseconds running it through my business logic. And I want my backends to respond fast enough to use up the rest of my time budget. And you might say, I want my RPC responses to run within 150 milliseconds. And these things they give you concrete goals. They let you say, where am I spending my time? How do I want to spend it? So without any further delay, I'll let Ryan come up here and talk about how you can use tools and techniques within the Google Web Toolkit to sort of fill in some of the blanks and some of the questions that I've raised in part one. Ryan?
So these are the topics I want to cover. These are basically techniques that I picked up while I've been using GWT. I want to start with going over a basic deployment scenario, something that's common with all GWT applications. Then I want to get into something a bit more complex, look at deploying RPC, a GWT RPC application to a servlet container. I'll look at automating deployment, because there's a lot of steps involved in deployment. You're going to want to automate to avoid errors. I'll look at some port issues that I've bumped into, and then some optimizations that you can do to your deployed application, including compression, caching, and bundling. So let's start by looking at just basic deployment with GWT. First thing you have to do is just compile your application with a GWT compiler. This translates your Java code into JavaScript, and you could do this by using the compile script that's generated if you generate your application with GWT's application creator. And you can deploy like it's 1995. In 1995, I was in my first year of engineering, and I was really impressed that I could go into the computer lab and get onto a terminal, type up a HTML document, throw it in the public directory of my account, go home and see it on the web. That really impressed me. It was super easy and distributed worldwide. Same with GWT technology. When you compile your application, files are generated by the compiler, and they're just general web technology files, including HTML, images, and JavaScript. You can just throw it up on any web server and download it in any browser. But of course, most GWT applications are going to have a server. And this is where the real deployment complications come into play. If you're using GWT RPC, you can use the hosted mode browser, which has embedded Tomcat, and it's fairly easy to have the server side of your application run side by side with this hosted mode browser. You don't have to really do a lot of deployment, but when you actually deploy this out to a real server or a test server, you have to worry about the actual servlet container configuration. So here's an example of the directory structure that comes with Tomcat. The directory that you have to pay attention to here is the web apps directory, which is open. To deploy your application, you just need to create a subdirectory in here and for your application and copy your compiled GWT files into this directory. So that's for the client side. For the server side of your application, you'll need to set up the proper web INF directory, which is also open here. The file in the web INF directory that's the most important is the web.xml file, which actually tells the servlet container where your GWT RPC servlet is going to be, the class name and the URL pattern that will be used to access your RPC servlet. And this is the same URL pattern that would be used by your client-side application to contact the RPC side of things. The other two directories here are the lib directory and the classes directory, which would hold your server-side Java code. The lib directory is going to hold your jar files, and classes can hold the expanded class files. So this is a lot of directories that you need to create and set up. And if you're doing this over and over, you're going to run into errors. It's a little bit cumbersome. So it's important to try and automate this stuff. I use Ant to deploy my applications. Ant's a Java build tool that is similar to a Makefile. Based on XML, you can run it from the command line. I also use it to deploy, and we can go over some simple steps of deploying basic deployment for GWT. First thing you can do is compile your GWT application with an Ant task. Here I have a target called GWT compile. It runs the exec task to just execute the script that comes with a generated GWT application. Now that might not make sense. It's an extra level of indirection to go and contact this or to load up this compile script. But as part of a build or deployment system, it's part of a dependency hierarchy. And so when you add it to a deploy system like this, it just becomes one extra component within the hierarchy. So to see this kind of dependency hierarchy being built, the second step in a basic deployment is to upload the files to a web server. And the second half here defines a target called GWT upload. It depends on GWT compile. So when you execute this target, it'll first make sure that GWT is your client side's compiled, and then it'll execute this target, which is going to run the FTP task and upload your file to a web server. So that's fairly simple. With one step, you're compiling and deploying your application to a web server. And you could do this from one command line, or if you have Ant integrated with your IDE, it's basically one click. So things get a little bit more complex when you need to deploy to a server. You could mess around with the directories on a server, but the preferred way to upload a web application to a server is to package it up in a web archive or a WAR file. So to build a WAR file, the first thing you want to do is compile your source code to make sure that it's ready for the server. And this is compiling the server side of your code, which is just using a regular Java compiler to compile your server side, your GWT RPC servlet. Then once you have that compiled, you can actually build the WAR file. And the second half here shows you a target called build WAR, which depends on GWT compile and this other server-side compile, so that when you go to build your WAR file, you're automatically generating or compiling your client side and your server side. And then it executes this target, which has one task, which is the WAR task, which comes with Ant, which will set up your WAR file automatically for you. You just have to specify the different components of the WAR file that need to go into it. And these are the same components that we saw in the directory structure in Tomcat before. You have your web XML file, which you should have in your project directory somewhere. You reference the classes that would go in the classes directory. And in this case, we're using what we've compiled in the previous step. The server-side code is classes. And you also need the GWT servlet in the lib directory. This is the GWT servlet jar is the library that you need to run your RPC server-side code, and it should go into the lib directory. The last set of files that are in the WAR file here is just the compiled GWT source code, which goes into the root of the WAR file. So this target builds up the WAR file for you. All you need to do is take that built-up WAR file, put it over onto the Tomcat server in the web apps directory, and your web application is deployed. Or the servlet container will actually automatically deploy your application for you. Of course, you could also add this step into the automation as well if you use some of the Tomcat Ant tasks, which don't come with Ant, but they come with Tomcat. If you copy this Catalina Ant jar file over to the Ant lib directory, you can use some of the tasks that come with Tomcat, including deploy and undeploy. And then you would just reference these tasks as task defs within your build file, and you could call these tasks. So here we have a target named deploy, which depends on build WAR, so it ensures the WAR file is ready and compiled. And then it calls the deploy task to upload the WAR file to your server. And it uses Tomcat's manager application to do this. The manager application comes installed with Tomcat. So running this deploy task is going to do all of these steps in one step. It kind of eliminates any manual deployment steps and a lot of issues that may come up if you do it manually. And it's a lot less cumbersome. Okay, now I want to talk a little bit about port issues. These are some things that I bumped into running GWT RPC on an Apache server, or on Tomcat, actually. Tomcat typically runs on port 8080. If you're running on a Linux machine, you probably have Apache running on port 80, and you have to deal with the port differences. It's not very friendly to tell people to go to your app at port 8080. So one way around this is you could put your client-side application on Apache and have your server on Tomcat, but you're going to run into the same origin issue because your client-side application is going to be loaded into the browser referenced on port 80, and then it's going to try and call your server-side on port 8080, and the browser's not going to let it because it's on a different port. The browser really restricts what a client can access, and that's the same origin policy. So the solution that I found for this is to install mod.jk in Apache, which is able to forward requests for specific patterns to Tomcat. And so what you can do is put your client-side application on Apache so that it's loaded from port 80. When it needs to request your RPC servlet, it does it on port 80 as well. Apache picks it up and recognizes that this pattern that it's trying to request is for Tomcat and automatically forwards it. So to the client, it looks like port 80, and the server's handling the forwarding. Okay, now we can look at some optimizations that you can do with deployment. First one I want to look at is compression. With traditional web applications, compression wasn't really, you could get away with not really compressing everything. Usually the heaviest thing in your web application would be images, and they're already compressed. But it becomes more important when you start doing AJAX and when you start doing GWT. Your applications can grow because you're building thicker, richer clients. And so it's important that you shrink these down. If you do use compression, you're going to be shrinking your application down about 70%. For gpoker, the application is only about 250 kilobytes, but when it's compressed, it's 70 kilobytes. And this is a huge difference, especially if you're running or your clients are on dial-up or slower connections. It also improves your bandwidth usage quite a bit. So to set this up on Apache, it's pretty simple. You just need to add this one line to the Apache configuration to set the output filter. You can set it by type, and it's set to just deflate, which is going to use gzip by default. And you can list the file types that you want to have compressed. Tomcat also has a feature that does compression based on file types, and it's fairly simple to add as well. You just need to set the compression attribute on the connector element in the server configuration file, set it to on. You could also set the file types that are compressed as well. Okay, so the next optimization I want to look at is caching. Caching is kind of interesting because the way HTTP servers and clients use caching is really optimized for traditional web applications. They follow this shared resource model where you have many documents sharing a few resources, so that when you load one document, it'll load all the resources initially, and then when you go to load another document, it doesn't need to re-download these images. But actually what it does is the browser, when it loads a second document, it still sends HTTP requests to the server to check to see if the resources, images, or CSS files are fresh in its cache. So it checks to see if there's updated versions. With AJAX applications, you don't necessarily need this extra feature. You can optimize things so that this cache freshness check is done as few times as possible. And that increases the startup time of your application. Ideally, the browser just checks for the version of your application using the no cache file, which is one of the files that's compiled when you compile your application. And this file is first loaded into the browser, and it actually checks which version to download. So this is the only file that the browser really needs to check for freshness for. The file is able to download different versions of your application, and different versions of your application are going to have different file names, and the file names are going to be dependent on the application content. So when you change your application, it becomes a new version. The GWT compiler compiles new file names, and you can handle these in an optimal way so that the browser caches them forever. And the way you do this is you need to add an expires header to these files, telling the browser that these files will expire a long time from now. This is a far future's expire header. So what happens when you load your GWT application is you load this one file that decides to load the proper version, and then those version files, if the browser already has them, it doesn't even send another HTTP request to check for freshness. And so you've limited your HTTP request to one for the application. So you can also add this expires header in Tomcat. Tomcat doesn't really have as rich support for setting headers. So you have to do it through a filter. To set up a filter in Tomcat, it's very similar to setting up a servlet. You just need to add these lines to your web.xml file, which reference the filter class and also reference a URL pattern of files to match and apply the filter to. And then, of course, you have the filter code itself. I've tried to squeeze as much code onto this slide as possible, but basically what it does is it's just checking to see if the file being requested is the no cache file. If it's, because you don't want to add the far futures expires header to the no cache file. You want the browser to check for freshness with that. Otherwise, it adds the expires header so that the browser can cache the file for as long as possible. So now the next optimization is bundling. Now with all these resources in your application, that you could use for your application. The browser, when you first load your application, the browser's still going to go out and try and load these resources one at a time, or two at a time, actually. There's a two connection limit per domain with the HTTP protocol. So this can slow things down. As you build your application bigger, you'll have more images, you'll have more resources with your application, and the more you put in, the slower your application loads. So the technique to get around this is to try and bundle these together into one HTTP download. GWT 1.4 provides an image bundle feature, which allows you to bring all your image resources together into one bundle. It's a really cool feature. At compile time, it takes a bunch of images, puts them into one image, so you can deploy this one image to the server. And then at runtime, it'll load that one image. And in the client, it'll use some CSS to display the correct image. And this is all done by generated code, so you don't really have to worry about the complexities of it. It's actually pretty easy to implement. Here's an example of declaring an image bundle. You just declare an interface, one method per image that you want to use, and you also specify the location of the image. The GWT compiler picks this up and generates the bundle for you to deploy. In your code, when you need to extract the images, you just need to create that image interface with with deferred binding, which is the first line in there. And then you could use that interface to call the methods on it to actually get the images. The methods return an abstract image prototype, which has a method called createImage, which creates regular image widgets that you can use in your application interface. So the next line here is just an example of the file that's generated by the GWT compiler. That's the image bundle. It uses a similar strong name as it does to your application file, so you can use expires headers in the same way. If your image bundle changes, the name's going to change, and you can tell the browser to cache these files forever. I also have an example of the gpoker image bundle here. It goes off the screen. It's pretty huge. There's 73 images in it. It's about 100 kilobytes, and it's downloaded in one HTTP request. So you could just imagine if this had to be done without an image bundle, you would load these 73 images two at a time. Now, images aren't the only resource that you may have in your Ajax application. You could use CSS is another type of resource that would cause another HTTP request, and there's images also associated with CSS. And there's no real way to handle that in GWT at the moment. But there's the GWT Incubator project, which is on Google Code, which is a really interesting project. It's where a lot of GWT features are being tested and could be in future versions of GWT. So one thing of particular interest here is the immutable resource bundle that's in the Incubator project. This immutable resource bundle lets you reference other types of resources, text resources or data resources, and it kind of provides an abstraction to handle these in the most efficient way for you. One example of doing this, using this immutable resource bundle, is using it for CSS. You could use this style injector class, which is also in the Incubator project. And you can use it to inject CSS text into your application so that it's not a separate file. And it also is able to do replacement of CSS images. It has one optimization that even inlines the images into your application so that they're not a separate file. So it's pretty interesting stuff, and it's really interesting to see where this is heading at solving the resource performance issues that come up with Ajax applications. So that's the last slide. I think we're ready to go into Q&A. Okay, sure. And I think we'll give away a book to Whoever wants to ask the first question.
Well,
okay.
The best question.
The best question? Do you want to decide what the best question is? No, that's not a good question.
That's too much responsibility for me. How about the question that makes the audience laugh the most, but it's still relevant?
It has to do with GWT, and it can't be a GWT joke.
And it has to make people laugh the most. So that's our basis.
Okay. First question over here.
We're looking at realistically that 300 is a nice dev kind of first person writing an app kind of goal, but the real goals you're looking at in the wild are Facebook's under 100 milliseconds, financial apps and anything real time is going to have to be under 10 milliseconds. Do you see Google WebKit being able to scale and be able to support tools in that space, especially with a lot of the apps being client side or local side and no file system access?
So I think that you're really talking about the presentation of the information.
Right.
When you talk about a 10 millisecond timeout or budget for real-time applications, that's really not something that you expose directly to the end user. So you want the presentation of the information to be quick. So I think that based on sort of human perception, anything faster than 150 or 100 milliseconds, you really aren't able to detect it that much. Oh.
Because you can't test and guarantee where your customer is, what their network is on. So on the server side, you've got to be
yes. Okay.
There so that it's under a second.
Absolutely. So the point the gentleman was making is that because you have no prior knowledge of the network and connectivity of your clients, you have to be super aggressive on the server side to minimize the budget there so that even for people who are on slower connections or marginal connections don't have a really terrible use experience. So you have to be very aggressive on the server in terms of your time budget.
Okay, next question.
We have this web application using GWT or GWT, and when we program it in hosted mode, we have this file called fusion.gwt.xml. There's paths in there that point to servlets and stuff. But whenever we deploy to a web server like Tomcat, the paths don't match the web.xml. So we have to change the paths, every time we deploy because they don't completely match. I mean, are you aware of anything like that at all?
Oh, right. So you're using the GWT XML servlet tag to map your servlets into hosted mode?
Yeah, the fusion.gwt.xml. I mean, we're using the XML that was already there, and it works fine in hosted mode. But I'm not sure if your question.
I'm not particularly familiar with that toolkit. But what I would suggest is that when you are running in hosted mode, and when you are running in web mode, if you wind up having paths on the server that differ, there is a method on the GWT object called gwt.isScript, and you can use that to select, which, you can do an if statement. Because the neat thing about gwt.isScript is that when we do the compilation in web mode, everything that would be, if that were to evaluate to false, anything in that if statement would just be elided completely from the output. So, using gwt.isScript kind of gives you for free, the ability to eliminate code when you compile compile for the web.
This question is related to caching. Is there any? I'll admit I don't understand the mechanisms of caching as well as I probably should. But is there any way to when you're deploying new versions of your application to sort of just force cache refreshes, and then that way you can kind of a little more haphazardly say this is permanently cacheable, but then always have a fail-safe kind of thing.
Okay, so sort of two parts to the question. Can you force cache invalidation? Sometimes it's not reliable. You look at certain major ISPs, they have been known to play interesting caching games with both content and DNS queries. So you really would not want to rely on any kind of forced cache invalidation. But that said, when you compile a GWT application, you will wind up with a bunch of files that have very long, just MD5 checksum names. And what's cool about that is that the name of the file is based on the content of that, if it's an image bundle, if it's a JavaScript output, if it's some other foo bundle resource. So the only file that really ever has to be up to date is the module name.nocache.js. And with that, because the browser will refetch it or at least revalidate it, even if it doesn't refresh it. You'll be able to always know that they are running the most current version of the application, because that no cache file has references to the particular strongly named files that it will then proceed to download, and your JavaScript will reference other strongly named resources, and then those will get pulled down. So we kind of file all of these issues under what we call the perfect caching is our goal there. So really, as long as you're able to ensure that the strongly named no cache files are generally well cached by browsers and or proxy servers, and the no cache file, as long as it has a fairly short lifespan, depending on how often you push your application, if you only push once a month, it's fine to cache it for a few days or whatever. And even then, make sure that you can specify particular cache headers, must revalidate. And that will also help browsers. You'll see the additional round trip, but the semantics of the revalidation are such that it might try to use a cached version while it's refetching. And worst case scenario is they just hit Control-R, and that forces the cache invalidation.
Questions back here? Keep us.
Okay, this is going to be sung to the tune of How Much Wood Would a Woodchuck Chuck? How many GWT developers would Google please if GWT supported Maven deployment more easily? Do you, or rephrase?
So, okay.
Now for clarity and not for a bid for the book. Is there any thought of doing a Maven archetype and some of those things to help people package their wars more easily, and also to have even nightly trunk builds to a Maven repository and that kind of thing, just to help us Mavenites out? Thanks.
Patches welcome. I mean, not to be trite, but really, we are an open source development community. We like to have people just, if you need Maven build support, we probably just don't have the engineering resources right now. There's so many things that we want to do that it's hard to find engineering resources within the team to do all this kind of stuff. It would be very useful. People would write you love letters, if you've supported Maven. So if you want to be popular, write a Maven wrapper for GWT builds. And if it works well, if there is adoption, then you either kind of become the de facto maintainer of that. And open source is really about people just stepping up to the plate and taking on kind of the ugly, nasty, grungy things and doing it. And we're very open to taking patches, to saying, hey, if you changed this little thing like this, it would make all the Maven stuff work better. That's the kind of feedback that we look for, especially we have a Google group, Google Web Toolkit contributors, which is where all of us hang out, and that's where the open source development takes place. So you're certainly welcome to do all the cool stuff that needs to get done if you do it, and can sort of say, hey, go here, grab this build file, grab this tool, grab that tool. I mean, there are all kinds of third-party components that people have built to satisfy their needs. So the gentleman in the back, in the blue shirt.
I think on the Maven side of things, it's more having a central repository where the jar files are downloadable from, which is really somewhere, that Google has to put it out there, because it's going to be com.google.whatever. I mean, if it's going to go out to wherever the central Maven repository is, it's going to have to be someone from Google who puts it out there. I mean, there are several plugins for Maven to actually do the compile and to do all that sort of stuff. It's having somewhere where, instead of having to download the file and put it in my local repository, having somewhere where I can point to the internet and say, this is where the latest, the current 1.4 build is.
Mm-hmm. Okay, and again, that's feedback. Feedback is the breakfast of champions, except when it's over the audio.
Next question.
Hi. I applaud you on your Apache compression ideas. The only issue I have with that is you're talking about dynamic compression. We have 4 GWT apps that are running on embedded systems, and we use static compression. So if you want to maybe explain to the audience how that works, we find that far superior to doing dynamic compression. Just because you know what, the server is going to be working really hard every time there's a request.
Right. Actually, I don't have a lot of experience with static compression, although I have been able to compress GWT applications using gzip and just putting the gzip files on the server, and Apache has been able to handle that correctly.
Right.
I'm not sure if that's C.
There are, I forget the exact module name, you might know offhand, that if you get a request for foo.html and there happens to be a file foo.html.gz in the same path, and the target browser supports gzip transfer, the Apache server will simply serve the pre-compressed version, and it does save you computational cycles, especially because the content doesn't change. The abcdefg.cache.html file is not going to change until the next time you push your application. So you can compress it as part of your build process, and presuming that you have either a servlet filter or the appropriate magic in your httpd.conf, you can wind up serving a previously compressed version of the resource instead, and that will save you computational cycles at runtime.
And I have an example in my book of writing a filter for Tomcat that uses static compression.
The one other thing, too, you have to be aware of is, as you mentioned, that cache XML file. It's fairly small, so when you compress it, it's actually larger when you do the compression. So you have to be aware of that. So if you statically compress everything, you'll see the files which you
files aren't necessary for serving your application.
No, I understand that.
Okay.
But if you're using some of those files, like we have a few XML files and JS files of our own, but if they're smaller than 2K, it's useless.
Sure. I mean, you always have to have a lower bound for when you apply an optimization, because sometimes any optimization when applied can be less optimal. Inlining, whatever, that kind of stuff.
Okay, we've got an app that's currently served over just plain old HTTP, and suddenly it's holding real data, and we'd like to move it to HTTPS. How much is there going to be any pain I haven't thought of aside from increased server load when I make that conversion?
It depends on your application. If it ever makes any assumptions that it's looking for like the HTTP string in a URL somewhere, that might be a problem. No, I mean, typically a GWT application should not care about your deployment strategy. We have tried to be extremely agnostic about the particular server platform, its implementation, your transport mechanism. GWT apps can run off of a file system. So if you had a document viewer, you could throw it on a CD-ROM file and load it from CD, and that would work just fine. So I would say as a general rule, there's probably not going to be a problem. But again, you have to test.
One issue with that is IE, for example, it doesn't cache SSL stuff.
Okay, so John was pointing out that there are some operational concerns. He pointed out one specifically that IE typically does not cache secure content, and these are issues that you will run into. Hopefully everything will work better in the future, but there are nits here and there.
Sorry, there is one other thing that fits us, which is iframes, where you don't have a source attribute. We'll give you a mixed content warning on IE, and we work fine on everything else.
Right. So, and again,
Again, it's one of those little things, but it's
yeah, I think with that one, if you use a JavaScript URL, that'll be fine. Yeah, and again, these are the perils of the browser as platform, and that there are many small quirks which are specific to the particular implementation of the browser.
Okay, this is an off-the-wall question.
Okay.
You guys have done a lot of your deployment to Tomcat. Has anybody deployed to the Equinox server and run it on Equinox?
I have no idea.
Anybody in the room? Okay, thanks.
Okay.
So I find GWT deployment really easy and flexible. So is there some feature, some advanced feature that you guys are working on? I mean, what's the future of GWT deployment? Is it it just seems perfect. So what could be done to actually improve it?
Thank you. But
Can I have the book? No, just
yeah. Flattery gets you a book. Yeah. Okay. Sure. But no. I mean the goals of GWT development is to make things as simple as is feasible to do so. You know, we like the fact that yes, you just get a bunch of static files, you pick them up, you copy them, and everything, you know, hopefully just works. In terms of deployment, you know, we have folks with a Maven build system. We could certainly stand to maybe, you know, have some WAR deploy targets for Ant build scripts. It's just kind of, you know, hand rolled recipes, you know, sort of a GWT build cookbook, as it were. And you know, there are things like that, but those become very specific to the particular app server, particular environment, and there are just so many of them that it's really hard to get, you know, resources to cover enough of it. And again, you know, we have people like Ryan. They write books. We have, you know, I think it's gwtsite.com that talks about all kinds of, you know, GWT related stuff. So if we haven't done it, somebody else probably has. We have this wonderful search engine. You may have heard of it, that will allow you to find things that have been published onto the internet. You're welcome.
Hi, I was wondering if you had any suggestions for writing the server side of an application that allows it to be easily or effectively load balanced across many servers. If you have any tips?
I haven't done much load balancing. It's kind of separate from GWT. Most of your GWT code is going to be running in the client, so I mean, you could pretty easily load balance the serving of those files.
I guess, do you have any tips in respect to server-side design that allow that to be?
There's actually going to be a talk on that. John Tamplin is doing a session. When is it, John? Right after this. Right here?
Right, but I'll only be covering that a very small.
Okay, so he will touch on that a little bit. Basically, you want to minimize the amount of session state required on the server, keep as much data as possible in the client, so that way it doesn't matter which backend you talk to. That is kind of the number one overriding factor in terms of making the application scale well on the back-end side of things. Certainly you want to have, you know, something which terminates your TCP and HTTP connections, maybe farms it out. Apache with ModJK and Tomcat is a pretty easy way to do this with just, you know, easily available open source software. You can configure ModJK, like Ryan had said, but in a fashion that will distribute the requests among multiple Tomcat backends. So that is one solution that's easy to pull off.
The other things you're going to have to look at as technology advances, those aren't clients. They're part of your server. So if you push to an SQLite and other web technologies, a lot of the apps there, since they're on persistent broadband connections, make them part of your actual steady home processing cluster. So you have an actual group of tools and actual people who are interacting with your application, where the more they use it, the faster it runs. Because they've got the resources there. If you're going to have a limited amount of resources out there, how big your NOC is on your server, so use your client's power.
Right. The suggestion here, just for the video, is that you're not just dealing with web browsers. You're dealing with useful computational units that people are running at home. Especially if you have Google Gears installed, you have a SQL backend, you have long-term persistent storage. You can make the client part of your serving architecture by offloading stuff as the clients become richer, as they become more powerful and more flexible. You can borrow the computational resources from your users. They will happily provide it to you as, you know, when you have a really good application that you're serving.
And you don't even have to worry about, like, a lot of the new ones that are more powerful and real good broadband are game mobile platforms and other mobile, but with stuff in memory, you don't have to install. I mean, I'd say Google Gears and Adobe Air are kind of intermediate because HTML5 is supporting client-side databases and browsers. So that means you can cache a browser-based app. We're calling it WebQ. So you got to think like that. If you don't, your architecture is going to blow up your actual things. That's why we're having to go sub 10 milliseconds. 300 is too slow. 100 on Facebook means 15 seconds on the client side, which is crazy for a broadband connected browser. I don't care what it's on. So the only way you're going to get there is if you use those resources.
Right. maximize the manner in which you utilize the computational storage and other resources of the client, the clients. Treat them just as additional nodes in your serving architecture. Send data, just go ahead and send more data than you need, stuff that you're probably going to need later on. There are all kinds of optimizations and enhancements that you can make to your serving architecture when you make the assumption that the client is very smart.